Let's take a look at a question from your lab assignment, section 2.3. In this particular problem, they want us to evaluate the limit. And then if it does not exist, we're going to enter DNE. Alright, so this is our limit. Limit is h approaches 0 of 6 plus h quantity cubed minus 216 divided by h. So in our first step, they want us to expand the numerator, and not just the numerator, but the first part of the numerator, which is a 6 plus h quantity cubed. Now remember that this is 6 plus h times 6 plus h times 6 plus h. And so when we look at it this way, we actually have to FOIL it out, and we probably would be interested in doing two at a time. So let's see if we can get this figured out. We're going to go 6 plus h times, and let's FOIL out the 6 plus h times 6 plus h over here, and that would be a 36 plus the middle term would be 6 plus 6, and so that would be 12 times h plus, and then we have h squared. So that's the first step, and then now we want to FOIL this out, or better yet, think about distributing either the 6 through and then the h through and then whatever else we need to do. So let's let's go ahead and distribute the 6 through, and imagining that we're going to multiply this whole thing by 6, and so these things are going to change. 6 times 36, I believe it's 216. 12 times 6, I believe that's 72, and h squared times 6 is just going to be 6. Alright, so that's the 6 part being distributed, but we're not done yet here. We're actually going to need to add this same expression being multiplied by h. And so let's take a look at that being multiplied by h. We got 36 times h, and then 12h times h, and then h squared times h. And so we're going to get this expression. Now we have a constant here, and that's the only constant around, but we have a couple of terms that have h's. We got the 72 and the 36, so we'd be interested in adding that. So let's copy this down for a moment. And then we're going to add the h's, so 72 plus 36. So 72 and 36 is 108. And then the h squareds can also be combined. That's 6h squared plus 12h squared. So 6 plus 12 is 18. So that is going to be the constants that they're looking for here, the coefficients. So the constant is 216 plus 108h, and then the h squared term has a coefficient of 18, and then we have the h cubed. Alright, so that's the first part. Now we go to step 2. Now that we have this information that we just found, we're going to subtract 16. And so if you take a look at the constant 216 and this constant 216 being subtracted out, then that's all you have left again. It's 108 times h, and then 18 times h squared, and then h cubed, all divided by h. So that part is taken care of, and now right before we take the limit, we see that there's a factor of h in the numerator that can cancel out with the h in the denominator. So after that happens, we're going to get the constants, or the coefficients again. 108 will become a constant because the h canceled. 18 times h, and then h squared cancels with the h and becomes, or h cubed cancels with the h, becomes h squared. And so this is what you have. Then finally, we're going to take the limit as h approaches 0. So in this case, since there's no more h in the denominator like we had before, by putting 0 in the denominator, you get something that's kind of weird. And so now that there's no more denominators, all we have to do is let h equal to 0. And there's a couple of h's equal to 0. That means these two terms, the 18h plus h squared, would go to 0, and all we would have left is 108. All right, so that is a simple example of doing limits analytically, symbolically, and we're done.